and go and full screen. Okay, so 17 firstly. We have y equal to log x8 plus x squared minus 8x plus 4. So firstly, we have 8 log x plus x squared minus 8x plus 4. Now I can calculate the derivative. It'll be 8 over x plus 2x minus 8 equals 0. And how do we simplify this? By multiplying by x. So you get 8 plus 2x squared minus 8x equals 0. So you have 2x squared minus 8x plus 8 equals 0. X squared minus 4x plus 4. And I can imagine right now Amjad asking me, does it matter? No, hang on, I'll try and do my French accent. No, I won't. Does it matter if I divide by 2 here? That's so close, yeah. No, it does not matter if you divide by 2. Right, so here it looks like x minus 2 equals 0. So you only got one answer, x equals 2. And if you put that back into the original, does somebody have that there, please? What is it going to be? Let's just look at it here. Oh, wait, hang on. It says there's 2 answers here.
No, it's the same. Yeah, it's the same answer.
All right. I have to delete one of those. So minus 2.4555. So yeah, that'd be a pretty typical exam question. We'll have a look at 28 next. There may possibly be a mistake in 28. So this was 17. And now this is 28. So we have y equals 9e to x minus 6e to the x plus 12x. So the derivative here will be 18 e to the 2x minus 6e to the x plus 12 equals 0. Dividing by 3. Yeah, dividing by 3. No, dividing by 6. 3e2x minus ex plus 2 equals 0. Now if you look at this, this is actually a quadratic. Can I borrow the calculator, please, Eamon? So mode 53. You did it already. So I suspect... Yeah, I think it's a simple sign mistake. This in the question, so you can make the correction here, that should have been a minus instead of a plus in the question. So that should be a minus there. That should be a minus there. And you get x equals 1 because I also tell you that x is a positive number in the question. So if x equals 1, then y would equal, let me see if I go back, that would be, let's type that in, 9 e to the power of 2 minus 6 e to the power of 1 plus 12. So it'd be 62.19 then. So I think I have to fix that at the back. Can you slide that down to Eamon? Yeah, I have 6 at the back. Way off. Right, so it should be a minus in the question and 62.2 at the back if you want to make the change. Alright, you can hand that back over to Eamon. Got that? So these are minuses now. I like this zooming out effect because each time it just gets smaller and smaller. So then for the next time I'll zoom out again and that would shrink even more. Okay. Yes?
Should I use the radial system? Or
Not important for this. There's no sine or cosine in it.
yeah, because I've got -1 here.
You got what?
-1.
For sure? I think it's 1.
-1.
2/3.
-1 or
There's 2 x.
yeah. What's the first one?
-1.
Oh,
Ah.
you put the -1 in 153. He forgot to put that.
Oh, okay.
Yeah.
So it is 1 then. Is one of the
Yes,
answers?
yes,
Yeah.
yes.
All right. Okay.
Like the middle one, you forgot to put -1.
Okay. Yep. Yes. Right. Next topic then. So we're going to look at something called the second derivative. And surprise, surprise, it's the first derivative twice. So for example, well, not for example, the second derivative just means you differentiate twice, which you can write like this, or you could write it like this with 2 dashes. So literally 2 differentiations and that's it. So for example, one example, y equals x to the 10. What's the first derivative? Well, that'll be 10x to the 9. And then what would be the second derivative? That'd be 90x to the 8. So second derivative literally means differentiate twice. You got that? Yes? Silence is good? Silence is good, okay. But what's the use of this second derivative? Well, let's have a look at some graphs. Oh, it's just getting weird now. Return to normal. Exactly. Alright, do you have that down? Yes. I'll write it here again underneath. So y second derivative equals 90x8. And as you're writing, Luna, it can help to tell if it's increasing or decreasing. So let's have a look at a graph to see why. Maybe actually I'll do my graphs and derive. So I'll just open it up here. Okay, so do you remember the first derivative means slope of tangent? So what's the second derivative? Well, second derivative tells us something more about the shape. So we'll have a look at an example here. And let's put in a cubic. Y equals x minus 1, x minus 2, x minus 3. Now, some students missed this last Friday, but we were practicing expanding here last time. Right, so there's our cubic. And let's draw it. Actually, I won't bother with the y, I'll just leave it like that. Okay, there we go. Reset, graph. Okay. All right, exaggerate a bit. So we can see where the two turning points are. There'll be one at around about here, which would be a max, and there'll be one around about here, which is a min. So at around about 1.5 maybe, and at around about maybe 2.5, there'll be a max and a min. Now let's have a look at the derivative. So derive can differentiate for us as well. So there's the derivative. Well, you knew that anyways. 3x squared minus 3x squared minus 12x plus 11. So let's draw this one. Now before I draw it, the derivative is the slope. So what's the slope out here to the left? Negative, positive, or 0? So it goes positive here, 0, negative, 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 0, positive, positive, positive. So we expect negative, 0 at 1.5 and 0 at 2.5. So let's draw it. And reset here. Negative, 0 at 1.5, 0 at 2.5, and then it goes off positive at the end. Yeah? Okay, now let's go back to the original one here. Uh-oh. Okay, if you were to imagine yourself standing here, the slope is positive, and then the slope becomes negative. So the slope goes from positive to negative. And if I go back to this one, this second derivative has negative slope. So the reason that this has negative slope is telling you that the one above it is going down. Maybe I'll draw some sketches here to try and help. Okay, so let me scroll down here. Alright, so there is my quadratic. Let's try to draw this function here. So if I have y equals ax squared plus bx plus c, what type of shape would this graph here be?
Linear.
It'd be linear. Now would the slope be positive or negative for this?
Positive.
Positive, because here a must have been positive to have this shape. So this one here should be positive. So positive slope is increasing. Now here should be where it intersects the x-axis. So for example, if I call this point here big X, then it must be 0 here at big X. Because what's the slope of the tangent here? It's 0. So that means in this function here, it should be 0 here. Yeah? Now, what's the slope of this line? Positive. So here's now where we have to use our imagination. So if I calculate the second derivative, I get 2a, which, what type of graph is 2a? Positive, but it's a constant, okay? So it always looks like this. So this means everywhere is positive, meaning on the graph above it, the slope everywhere is positive. Is the slope everywhere positive for this? For this one here, it is, yeah. But for this one, it's not. Now, again, let me look at a cubic now. Let's make it a bit more complicated. So, cubic. Okay. So the slope here starts off as positive, then it goes 0, then it goes negative, then it goes 0 again, then it goes positive. So let's try and draw that. So it starts off at positive, but if it goes from positive to 0, is it increasing or decreasing? Decreasing, so it's going like this. And then it hits 0 slope, and then it goes negative slope, so it goes down. And then what happens when it hits here? 0 again, so it must go back up. And then finish, the slope is positive. That's not too surprising, because if you differentiate a cubic, what shape do you make? You make a quadratic. Now, let's differentiate this again. Okay. So the slope here, to begin with, what is it? Starts off as negative, it's going down, and then it becomes 0, and then it becomes positive. So it goes negative, 0, positive. That's a straight line. Negative, 0, positive. So that's like this. Okay? So my point is, the second derivative can tell you something about the derivative. If this is, okay, I'll get straight to my point. There's enough messing around with graphs. If the second derivative is positive, what that means is the graph will have this shape to it. And if the second derivative is negative, it means it will have this shape to it. I was messing about with graphs a lot there, but my point I'm trying to make is that the second derivative will have will have this U shape to it, and a negative second derivative will have this hill shape to it. And there's some vocabulary around that. I wonder if anybody knows the vocabulary to describe this shape and this shape. Ah, yes, but which is which? Yes, that's right. So is that the top or the bottom? Yes, good. This one is called a concave shape, and this one here is called the convex shape. The reason you can remember this, because this one looks like a cave. Yeah. Now, I was told, and I still have to check this out, somebody told me in some countries it's actually the other way around. I was told in South America, when you translate it to Spanish, it's actually the other way around. I don't know. I'll have to check. So I'm just saying, if this is the other way around, maybe that's fine for your country. In fact, I think in the States, in America, they don't even use concave or convex. Really annoyingly for me, they use the word concave up and concave down. So they don't even use convex. Is this anyone American system? I don't know. Anyways, not to worry about the vocabulary. Here in Ireland and the UK, we use concave and convex. Okay? Right, so let's have a look at some examples then. So all I really need you to take down is that result there, that a positive means that and a negative means that. By the way, what happens if it was 0? Yes, could be linear. In fact, it might not be. But if it's 0, it's unclear. So we cannot say anything about its concavity or its convexity if it's 0. So in other words, if it's 0, we have no extra information. Not that it's concave, not that it's convex, we just don't know. Inconclusive, no more information, okay? So let's have a look at some examples then. So the first question, I'm going to skip, because all I ask you to do is to calculate the second derivative, which just means differentiate twice. So more importantly, for me to show you is the second one, number 2. So I give you this curve here. And like before, I want to know where's the max and min. But this time I want you to tell me if it is a max or if it is a min. So what's the derivative here? Minus 2x minus 14 equals 0. Therefore, x equals 7. And then what will we get for y? Minus 7. And y will equal, when you sub it in, 45. Now, we have to know if it's a max or a min. We already know the answer, because what shape is this minus quadratic? It's this hill shape. And using our new vocabulary, what's the name of this hill shape? Concave. So we know that it should... Remember? Cave? So we know it should be concave. And we know that it should be a max. But the way we check is we calculate the second derivative. So what's the second derivative here? It's minus 2, which is negative. Negative, if you remember, means concave. So that means we have this shape here. So it's a max. But not only is it a max, it's in fact, we say a global max. Because it is the maximum for the whole graph. Do you remember what's the other vocabulary I gave you last week? It's global max, and then what's the other one? Local max. I'll do a cubic next to show you this maybe in more detail. So we'll do F next. What's wrong? Yeah.
Why that means the second derivative, right?
Yep.
No.
No. All right. Next one now. Y equals 2x cubed minus 3x squared minus 36x plus 36. So first derivative would equal 6x squared minus 9x minus 36 equals 0. So when you solve that, you get x equals, well, we'll just go straight to it here, minus 2 or 3. So when x is minus 2, you get y is 65, and when x is 3, you get y is minus 45. Yeah.
6x squared minus 6x.
Huh? 6x squared minus 9, yes, sorry, 6x. I think we'll have to close the blinds at the back there. Do you mind getting those two at the back? Oh, that's fine. Yeah, we're done. Okay. Now, one of these will be a max and one of these will be a min. So the second derivative here will be 12x minus 6. Now what's slightly different here is it's not a constant, whereas in the last one it was. So what we need to do for this, we sub in minus 2 and we get y second derivative minus 24 minus 6. I know it's definitely going to be negative. I don't even have to work out what the number is. Okay, so then if I put in 3 into this now, I get 36 minus 6, which is 30. So we get then for the second one positive. Okay. Now, negative, what shape is that? Concave or convex?
Convex.
Convex. And then positive? Concave. Isn't that right? Yeah? So convex is this shape. Wait a second. I think you gave that to me backwards. Negative is concave. Yes. Concave. And positive is convex. So concave is this shape, but then it switches to convex. Yeah, sorry, concave is a cave. Concave is this shape when x is minus 2. So here is x is minus 2. And then what happens when x becomes 3? It's convex, which makes it switch into this shape. So it starts off as concave at minus 2, and then when it hits minus, that graph is totally wrong, of course. Like, I mean, I should have a y-axis like here. So at minus 2, it's concave, and then when it hits 3, it gets convex. So it'll start off as a cave and then down as a valley. So this one here is a max, and this one here is a min. Now, would this be a global or a local max? What do we think? It'd be a local max because it continues to go up to infinity here. And what about this one? Also a local min because it continues to go down to infinity there. Okay, write that example down. And
Global max.
no global max. Because there's no point on the graph that's always above everything else. Because it just keeps going to infinity. There's no roof. You know what I mean? I'll leave that there, but let me draw a nice one for you. Can you call it out to me? What was it? I don't have it here. Something x cubed, wasn't it? Was it? 2x cubed minus 3x squared minus 36x plus 36. Let me zoom out a bit. Okay. Too much. See? At minus 2, it's a max, it's a concave shape, and then when it hits 3, it's a min because it becomes a convex shape. Right. So I'll do one more or two more examples, yeah. Okay. You know what? I'll give you like enough time it takes me to take a couple of sips of this coffee. Did anybody go to the parade yesterday? Yes? Good time? Anyone else? Yep. Good time? Muna? No? MB? Yes? What? Yeah, I know it's not exactly Brazil. It's all right, you know? Yeah, I know it's not like Carnival or anything, but it's okay. All right, next example now. So I would like to know where is this function here. Is that bothering you, Muna? I would like to know where is this concave. So I want to know for what part of the graph is this concave. So what do you think I need to do first before I can answer that? Derivative. So first derivative would be 9 x squared minus 18x plus 6, my first derivative, and my second derivative will be 18x minus 18. Now, if I wanted to be concave, do I want my second derivative to be a positive or a negative? I want it to be negative. So what does that make for x? 18x must be less than 18. So x must be less than 1. Or in other words, if I write less than 1, what's that interval from where to where?
Infinity.
Not infinity, but rather minus infinity to 1. So in this part of the graph, it'll be a cave shape. Well, that's what the next point I'm going to get onto will be. Wait a second. Did I have this backwards? Concave is this shape, which is a negative. Yes. Hill. All right. But something feels wrong. From my feeling, something feels wrong. And let's look at the graph for this. So back to our derived program. Okay. So we have 3x cubed minus 9x squared plus 6x plus 5. So I need it to go cave at the start. Ah, it's weird, that's why. Okay. Oh yeah, whatever. Sorry. Right, if you look here, it's going up, up, and top here. So it is like a cave shape, isn't it? But then, if you go too far right, it'll turn into this kind of valley shape. So only up to the point number 1. So I can't really cut it off the screen here. Oh, actually, I know what I'll do. Yeah. So you see here, you see it's a cave shape for sure. But then if you go too far, it starts to turn into a valley shape. So that point there is the point 1. See, minus infinity to 1. Now, as you were saying, do we include 1 or do we not include 1? Well, in fact, in this graph here, we don't include 1. It's a special point. So at x equals 1, that's when it changes from being a concave to a convex. That has a special name. This is called the inflection point. So inflection means when you switch from concave, changes into convex, or if convex changes into concave. Yeah.
Is it like a turning point?
See, then it gets really complicated, so I don't want to go too deep into detail, but it's a type of turning point. A turning point for the first derivative, kind of. So if you were to give me a formula, how do you think you could find this point here? What? You're just rambling things out. No. It's when it changes from concave to convex. So if you look at my example here, I don't use x equals 1. What would happen if I put 1 into this second derivative here? What would I get? 0. So recall earlier I said if it's 0, we don't say it's concave or convex. In fact, because it's not concave or convex, it's switching between the two. So if the second derivative is equal to 0, then it's transitioning from a convex to a concave or vice versa. However, I must give you a little word of warning. It's very important too, or not very well, it's useful to note that you need the first derivative not to be 0 at this point. Because if the first derivative and the second derivative is 0, then it might not be concave, it might not be convex, and it might not even be an inflection point. Then it could be something called a saddle point, which is not on the course for semester 1. So we have 3 key regions. We have concave. So second derivative for concave must be negative. Convex, the second derivative should be positive. An inflection point, it has to be 0. However, we cannot have the first derivative being 0 there as well. Because if the first derivative is 0, then what type of point would that be? Well, what does the first derivative being 0 represent? What type of point is that? Max or min. So it's where the graph flattens out. But then if it flattens out, and then the second derivative is 0, then it changes from concave to convex. So it goes concave, flat, convex, or what? You know, it gets more complicated then. So just to prevent all of that, I'll say we don't want the first derivative to be 0 as well. So maybe I can summarize our results as follows. So if the first derivative is 0 and the second derivative is positive, is that a max or min? Is it concave or convex? What shape is it?
Convex.
It is convex, so it is a minimum point. It goes like this. If the first derivative is 0 and the second one is negative, it's a max because it goes this shape. If the first derivative is not 0 and the second derivative is 0, then it's transitioning from being concave to convex or vice versa. So it could be going like this, or the other way around too. Now, this last one here has only, I said it's not on the syllabus. It did come up in the exam once, and if I remember correctly, students got marks even if they did it wrong, because it shouldn't really have been on the exam. But since it was on the exam, I feel like I should show you just in case it happened again. What does happen if the first derivative is 0 and the second derivative is 0? I ask you to describe what happens at some point x equals 1 or whatever. How do you know if it's a max or if it's a min? So for example, e.g., let's say x equals 1, y equals 1. So if I scroll down a bit, I want to know if it's a max or if I want to know if it's a min. This one here just tells me it's a turning point, but I knew that already. This one here doesn't tell me if it's a max or a min. How can we decide what shape it is if we don't know here? Well, what you do in this rare situation is, in fact, you just take 2 points very close together, like 0.9 and 1.1, and you draw them. So, for example, if your 2 points were above, then we can see it's a min. If your 2 points were below, we can see it must have been a max. And if there was 1 point below and 1 point above, then it's not a max or a min. We say it's no, not even inflection. It's just, well, it's, okay, inflection, but it's a rising inflection point. And then if one was above and then the other one was below, then it's falling. Now, I don't want to spend any time on that one because, like I said, it came up once in the last 5 or 6 years by mistake. So this is not something to worry about. What comes up every single year is these three here, and they're the most important three. Okay. Homework time. Let me tell you which ones to do. I would like you know what, I'd like the bottom row of number 1 first. So that's E, I, N, or B, Z, the bottom row. Yes. Yes? E, I, N, or B, Z, the bottom row of number 1. Did you write that down? You got that? Number 2, let's see, I'd like a quadratic, cubic, and a log. So, I think nice enough then that would be WXY. WXY is a log, yep, a cubic and a quadratic. Okay. Number 4. Number 5. Number 8. Slow down there. Number 16. Yes, that will do. I see. Alright, so just to repeat for the slow folks. Number 1, I want the bottom row, E, I, N, or B, Z. Number 2, W, X, Y. And then after that, I want 4, 5, 8, and 16. 4, 5, 8, and 16. So I'll check those. We have class tomorrow. We have class tomorrow. You must be getting, we must be near, I think there's only like 4 lessons left, is there?
4 lessons
For this semester, yeah. We have practical problems to do after this, isn't it? Like how many worksheets after this one?
10.
Yeah. Yeah. 5, and then we hit revision. So we'll finish at early next week. No, we might. How many more classes do we have now? We missed 2 yesterday or 1? We missed 2. So we only have 3 left. Yeah, so we won't start the revision till next week then. But we have only 2 weeks left? Or 3 weeks?
3 weeks.
2 weeks.
No.
2 weeks or 3 weeks?
How many weeks?
2.5 weeks?
Yeah.
2 full weeks and the rest of this week?
No, including this week, right?
Yeah.
Because remember, we got an extra week though added at the end. People don't read their emails, I could say. When do you think the last class is? What day? 28? I thought it was pushed to the 4th of April. I thought we got an extra week, no? An extra study week. Yeah.
We didn't receive that.